find the x-intercept and the y-intercept of a line. Two ways to do this. The first way is with the graph. Your x-intercept is where your line crosses your x-axis. Your y-intercept is where your line crosses your y-axis. Simple as that. If you don't have a graph, it's actually the same exact math to find out what your x and your y-intercept is. What I mean by that is, on a graph, your x-intercept is always whatever the x value is, comma 0. Or, to put it in other terms, whatever x equals. Your y-intercept is always 0, comma your y value, or whatever y equals. What you're doing to find these intercepts is, for the x-intercept, you're setting y equal to 0, which means that in your function, whatever you see y at, make it 0. Your y-intercept is you're setting your x equal to 0. So wherever you see a 0 in your x in your function, set it to 0. So let's use it for this one. I have 9x minus 4y equals negative 15. For my x-intercept, I have 9x minus 4 times 0. I'm setting my y equal to 0 equals negative 15. And then from here, I would just go on and solve my function. 9x minus 0 equals negative 15. Divide by 9. X equals negative 15 ninths, which can be reduced to negative 5 thirds. That's my x-intercept. It's just negative 5 thirds. My y-intercept is the same problem, but this time my x equals 0. And now I solve. 9 times 0 is 0, so negative 4y equals negative 15. Divide by negative 4. Y equals positive 15 fourths, which cannot be reduced. And that's how you find x and y intercepts. If given a graph, see where your graph crosses the x and y axis. And if given an equation, set your x equal to 0 for the y-intercept, and set your y equal to 0 for the x-intercept. Why are you doing these things? Because if your x is 0, you only have to solve for y for your y-intercept. And if your x is 0, you're only solving for x for your x-intercept. And that's how you do problems like these.